Hi, the purpose of this video is to show you how to derive these Pythagorean identities. So you might be using these in your class and your teacher has you memorize these. So in case you want to know how do we get these, so you don't have to memorize them, let me show you how. So these are your three Pythagorean identities. I'm going to start off with the unit circle. So I'm going to draw a circle here. And it's a unit circle, so the radius is 1 unit. That means this point right here is 1, 0. This point here is 0, 1. And I'm going to draw just an angle anywhere. I'm going to place it right here. That's our angle. I'm going to call this angle theta. And this angle theta intersects the unit circle at some point. This is some x coordinate, comma, some y coordinate. So this point is x units from the origin and up y units from the x-axis there. All right, so if I draw a right triangle here, we know this base length of this triangle would be the letter x, and the height of this triangle would be the letter y. Now, because this is a unit circle, the hypotenuse will be 1. From this point here, from the origin, this point on the circle, that'd be the radius of the circle, and since it's a unit circle, that radius is 1. All right, so now we're going to use the Pythagorean theorem to write the equation x squared plus y squared equals the hypotenuse of 1 squared. So that simplifies to x squared plus y squared equals 1. All right, now we're going to use the sine of theta. We're going to determine the sine of theta and cosine of theta, and we're going to use those in just a minute. So I'm going to write down the cosine of theta. So given this right triangle, the cosine of the angle theta, if you're familiar with SOHCAHTOA, cosine of theta given a right triangle here is the adjacent side x divided by the hypotenuse of 1. So that's just equal to x. Now if I evaluate the sine of theta, remembering SOHCAHTOA, the sine of an angle given a right triangle here is the opposite side of the angle. That would be y divided by the hypotenuse of 1. So that's y divided by 1. And this equals y. Okay, we're so close to finding our first Pythagorean identity. We're going to use substitution. I have this equation x squared plus y squared equals 1. We derive that using the unit circle here and the Pythagorean theorem. Now, see where it says here x equals cosine of theta? I'm going to replace x with cosine of theta. So I'm basically taking this equation here and I'm replacing x. It's equal to cosine of theta. So x is equal to cosine of theta, that's squared, plus y squared is right here. I'm going to replace y with what it's equal to. It's equal to sine of theta equals this 1, this orange 1. Now, I'm going to rewrite this using different notation. So for the record, cosine of theta squared, this notation here, is equal to the cosine squared of theta. These are equivalent. They mean the exact same thing. They just look different. You want to be very careful that you use parentheses. See how I don't have parentheses around the cosine theta here? That means it's actually theta is being squared. This is equal to cosine only theta is being squared, and then you're taking the cosine of it. So it's really important that if we want to write cosine of theta, that quantity squared, it has to be in parentheses, or we use this notation here, which is great. So cosine squared theta plus sine squared theta equals 1. So if your teacher told you to memorize this, now you understand how it was derived, how we got it. All right, that is one of our 3 Pythagorean identities. Now the other 2 is going to be easy peasy to derive those. So they all stem from this one right here. I'm going to divide. We're going to take this Pythagorean identity and we're going to divide by cosine squared theta. We're going to divide both sides of this equation by cosine squared theta. So I'm going to take this equation here. I'm going to divide both sides of the equation by cosine squared theta. Now I'm going to distribute this division, just like multiplication. I'm going to divide this into each of these terms. You're not allowed to cancel terms. So if you want to cancel these terms, that's illegal. You'd have 1 plus sine squared of theta, which is wrong. You have to distribute this, divide this in each of these terms. So it's cosine squared of theta divided by cosine squared theta plus sine squared theta divided by cosine squared theta equals 1 over cosine squared theta. This represents the reciprocal of cosine squared theta. So this is equal to secant squared theta. Now cosine squared theta divided by cosine squared theta, that reduces to 1. And I hope you're familiar with this, but the sine squared of theta divided by cosine squared theta is the same thing. It's equivalent to tangent squared theta. So when you see sine of theta over cosine of theta, you should think, oh, that's tangent of theta equals secant square of theta. So this is another one of our Pythagorean identities. We derive this one right here by using the Pythagorean theorem. So now we have these 2. Now we just have to derive this last one here. So you might be able to figure this out. We're actually going to take this Pythagorean identity here. And in the previous part here, we divided everything by cosine squared theta. Now we're going to divide both sides by sine squared theta. Again, we're going to distribute this division. We're going to divide this into each of the terms in the numerator. So this is cosine squared theta divided by sine squared theta plus sine squared theta divided by sine squared theta equals 1 over sine squared theta is the reciprocal. It's equal to the reciprocal of sine squared theta, which is cosecant squared theta. Cosine squared theta over sine squared theta. Notice up here when we had sine squared theta divided by cosine squared theta, it was tangent squared theta. So this will be the reciprocal of tangent squared theta, which is cotangent squared theta. Plus sine squared theta divided by sine squared theta is 1 equals cosecant squared theta. This is our 3rd Pythagorean identity here. Now notice, it might look a little different. I wrote down the cotangent squared theta plus 1, but you can just use the commutative property of addition and just switch the order of those 2 terms there. So the purpose of this video is to show you how these are derived, in case you didn't want to memorize them. As long as you can derive this first one, you divide by sine squared theta and cosine squared theta to get the other 2 Pythagorean identities. And we're going to use these to establish identities and to simplify trig expressions. And simplifying trig expressions is likely to be on the free response exam for the AP Pre-Calculus. So there's a couple more videos here for you to check out if you want to see these in action. All right, thanks for watching.